So in this example, we're going to take a look at the different constraint workflows that we have when we want geometry to stick to another piece of geometry in the 3D system. So we have this car and there's animation on it. This animation is coming directly inside of Nuke, just on a geotransform. This is not from the 3D application. This is just for demonstration purposes. So we have a card, and what we want is this card to be able to stick to the car. So how we can approach this is we have these options to snap directly inside of the card itself, and we can also snap to an animated vertice. But we don't want it to bake that information directly onto the card. So what we'll do is we'll create a geotransform, and then we'll do that same functionality on the geotransform itself, and this will give us a little bit more freedom. So in this case, what we want to do is select a vertice. So we'll select our car, say the license plate, and jump to vert, and then select some. And then in our geotransform, we'll just snap it into position. So when we do that, we have it snap into position, and you can see where it snaps is from where the pivot is placed. Now that's not helping us because our car is animated. So what we can do now is we can snap the geometry to the animation of that vertice. So we'll do from frame 1 to 100. And then now we have that information baked in. So because we did this on the geotransform, this also gives us the freedom to go in and move the card and position it how we want from the actual geocard node itself. The geotransform is holding the animation values. And so now that we have this card that is traveling along with the car. Now the thing with this workflow, it is completely functional. However, if the animation of the car changes, then what we need to do is to break the animation and then rebake it. So let's look at another way that we can do this. So I'll delete the geotransform, and what we'll do instead is we'll create a geoconstrain node. Now, when we do that, what we first need to do is to select the object that we want to be constrained to something. So that's the card. And then it's saying the target object is not transformable, and that's because we don't have anything in the target path. So what I'll do is I'll go in and select that license plate again, and let's see which object that is. That is, oh, I should actually look at it there. Object 43. So in this case, I'm just going to go ahead and grab that as my target path. So now let's go in and look at it. The errors are cleared up. I have my card, and we can see what happens is currently the card is set to a look at constraint. So it's looking at the car as it drives by, but we want it to be a parent constraint. So now when we do that, now it is traveling alongside of the car as well. We can maintain an offset for it, so we can also keep that original offset of its position of where it was placed in 3D space. And then we can also fine tune if we want to place it into position just like that. And then now we have it constrained. So this is a more nodal approach, and this means that if the animation of the car changes, it'll update. This node will update to wherever the new animation is, and then we'll still have that constraint. Now, another way that we can constrain if we need to be more precise is that let's create another constraint. And this time what we'll do is we'll actually still do the same objects. So we want our same card, and we want that same object as our target path. But this time what we want is to grab a face, because we can do a face constraint. So if we select our license plate, I'm going to jump over to face selection mode, and then let's look at the card. Let's just move it out of the way so we can actually see the license plate. And then we're going to change the point of origin. We could choose vertex, or we can choose face. And then the face, we'll use the picker, and then we'll say we want it to be on this particular face. And then what we'll do is we'll change it to parent. And then we'll turn off rotation so it goes into the correct position. So now as we move, we have it constrained to the face. We can still do that same offsetting with the card if we want to as well.